In the previous examples, our RAM ICs had words of a single bit width. Now we are interested in increasing the width of our words. Indeed, we want to have words which have more than 1 bit as their content. Over here, you can see how we can do it. We have an example of 8 by 2-bit RAM. Okay, so we have the RAM which has 8 number of words, and in each word we have 2 bits. Since we have 2 bits, the data input lines will, the size of the data input will be 2. Obviously, for the data output, we will have 2 bits as well. We have 8 number of the elements to select among. For the row select, we will use 2 to 4 line decoder. So with this 2 to 4 line decoder, with A2 and A1 address lines over here, we will select the rows among the one of the rows out of the 4 rows that we have will be selected. And then for the column select, we will use 2 pairs of columns at the same time. Okay, so this is important because we want to increase the width of our words. Instead of having a word with 1 bit, we want to have a word with 2 bits. Therefore, we select 2 pair of columns at the same time. If you look here, we have the 1 to 2 line decoder. A0 is the main input. We have 2 outputs from it. And those 2 outputs, each one of them, are connected to the bit select of 2 RAM slices. Let me show it for one. So you can see this one is connected to the bit select of these 2. So these 2 RAM slices, the first and second column, will be selected at the same time. On the other hand, we have it similarly for the next 2 columns as well. Yeah, so bit selects are connected to each other, so those 2 will be activated at the same time simultaneously. Then for the data input, we have 2 lines, data input line 0 and 1. You can see that the data input line 0 is connected to the data input for the first column, and it is connected to the data input of the third column. And similarly for the data input line number 1, it is connected to the data input of the second column and the fourth column. Read write is common among all of them, so they all are connected to the same signal, to the same command, read and write. And in terms of the output data, we have the OR gates receiving data. So we have one OR gate here, one OR gate here. The first one is used to give us the bit number 0 for the output data, and you can see that it is connected to the data out of the first and third column. And similarly for the second one, for this one, it is connected to the data out of second and the third one. So basically, with any address that we provide for A3, A2, A1, we will select 2 columns, either these 2 or these 2 at the same time, and we will select one of the rows. So let's say this could be one example. So these 2 could be selected with a given address. These 2 could be selected with another given address for A3, A2, and A1. And then depending on what we have for read write, then we can write into the memory, or we can read the data from the memory. We just keep in mind that now the widths of our words are equal to 2 bits. Okay, so 2 bits at a time. We will either read or we will write. So this is how we can expand the widths of our memory elements. and then we will have words which have more than 1 bit as their content. Now we want to increase the size of our memory by using smaller memory blocks. Over here you can see an example in which we are using 64K by 8 RAM memory ICs. So we are using 4 of them, and we are going to construct a bigger one. So with this configuration that you see here, we are not going to increase the width of our words. So we will still use words with 8 number of bits. But we are going to increase the size of our memory in terms of the number of the words that we will have. So in this way of doing it, we pick the, let's say, some bits of our address. So in our address, we in total we have lines 0 to 15, or let's say 16 lines over here. 16 lines for our address and 2 lines here. The 2 most significant bits of our address lines will be used in order to feed to a 2 to 4 line decoder, out of which we will get 4 outputs, and those 4 outputs will be connected to the chip select of the memory, the smaller memory ICs that we are going to use. And you can see them here. Okay. So with those 2 lines of the address, one of these smaller memory ICs will be selected and they will become active. The next 16 least significant lines of the address, as you can see over here, will be directly connected to the address input of all of those memory ICs. So all of them will be connected to each other and to these 16 lines of the address. For the data input, we have 8 data input lines. They will be also connected directly to the data input of all of the ICs that we have here, as you can see here. And similarly for the read-write, we have a single read-write command, and that will be connected directly to the read-write input of all the memory ICs. So with these 18 lines of address, we will pick an element in one of the smaller memory ICs. And then depending on what we have for read-write, the data that we have at the input side, we can write the data into them, or we can read. But when we read the data, for our data output, we need to kind of connect the data output from all the memory ICs to each other. So in this case that we are using the 3-state bus, they can be connected directly to each other. At any time instance, one of them will be active, and therefore we will get the data from that IC, and that could be used as our output data. So you can see how the whole procedure is done. Yeah, we just put the memory ICs one underneath the other one. We use the least significant bits of address lines in order to provide the address to each one of them, and the most significant bits in order to pick one of those ICs. This is the general approach that you can take in order to increase the size of your memory by combining smaller size memory ICs. And over here you can see the address range for the bigger memory that we have obtained. Again, the most significant bits, bit number 17 and 16, are used in order to provide inputs to our 2 to 4 line decoder over here. You can see that the outputs are connected to the chip select inputs of the smaller ICs. Read-writes are common. Then the least significant 16 lines of address are connected directly to the address input, and the outputs are connected to each other. Data input are also shared among them. And here you can see that for the last one over here, this is the range of the address. So when address 17 and 16 are equal to 0, 0, then with the remaining 16 we will cover memory addresses starting from 0 up to FF in hexadecimal, and similarly for the next one. So this is the range of the addresses for this, and for that. So this is in it how we can expand our memory in terms of the number of the words that we want.